Greetings all. Today I want to talk about the TMS 9900 by Texas Instruments. This is the last one I'm going to talk about. This one is a little bit different than the ones we've talked about so far in that this one is a 16-bit processor. The others were all 8 bits. This one came out in the mid-70s. And it was kind of late to the game, and it also did not catch on very well. There are several reasons for that. One was the fact that they came to the game a little bit late. Another was there are no real onboard registers. All the registers that are used are in RAM. This is a benefit, and it's a debit too, in that having the registers in RAM, in the processor there is a register. It's called the workplace pointer register. That register is set to the address in RAM of where the general purpose registers are located. Now this implies that you can have more than one set of general purpose registers, which makes it very, very easy for context switching, which is good for multitasking and subprogram or subroutine execution. However, that's also a bottleneck. So it's a curse and a bane, both at the same time. Another is cost. These processors were a little more costly because they had such a large die size. And in addition to that, since they have all 16, actually they have 15 of the 16 address lines outside the package. They also have a 16-bit data bus outside the package. Plus there are control signals in your power supply and clock and such. So they were put in a 64-pin ceramic package that was a little bit larger than the standard 800 mil. So with all of those things, this was it was really outpriced in the market. It was just too costly to adopt. Another reason it wasn't adopted very well was because TI insisted on controlling every aspect of their processors and their products. They wanted to do the software. They wanted to write the operating systems. They wanted to be involved in everything, and most users didn't want that. They wanted to be able to do their own thing. And when they implemented this in the 99.4 home computer, the home computer only had an 8-bit bus available in it, or implemented in it. So to write to memory or read from memory required 2 separate cycles, 8 bits at a time, which was another bottleneck. This also takes a 4-phase clock and multiple power supplies, which all of these things added together just pretty much doomed this processor for the general market. There are some niche markets that use it. TI's best customer was TI themselves. It probably got the most use in the 99.4 home computer, of which there were many thousands of them sold over the course of a couple of years that they were being made. So that's pretty much it. There is a block diagram here. And you can see that there's the control logic functions are here. The ALU, the address multiplexer, you got your program counter and stuff up here. This does have a serial communications method. It's called CRU, Communications Register Unit. And this is 4,096 bits of serial I/O that can be used independent of the data and address bus. You can talk directly with peripherals through this communications register unit. That is one plus that this had that no other processor had or has today that I know of. But again, that was just one thing that it was a positive, but it wasn't positive enough. It didn't add enough weight to outweigh some of the other negatives, like cost, availability, expense of development tools, and then TI had to have their hand in everything. So all of those combined pretty much doomed this processor for the general market. Also, it was a little more expensive and a little more involved or complicated to program. So all of those made it pretty much a relic. It just wasn't adopted. So anyway, that's pretty much it for the 9900. I think I've got one more video that will summarize all of the processors I've looked at. It will be short and sweet also. So until that one comes out, adios.